Okay, so this is number 23 on chapter 4. A fireworks rocket explodes at height h, the peak of its vertical trajectory. It throws out burning fragments in all directions, but all at the same speed v. Pellets of solidified metal fall to the ground without air resistance. Find the smallest angle that the final velocity of an impacting fragment makes with the ground. Okay, so we have a rocket, and it's up here, and it explodes. And if this is the ground, then this is height h. So pellets are thrown out, all at the same velocity v. The question wants to know when the rocket lands, it will have a velocity. We'll call it v final. It wants to know the smallest angle theta that the velocity makes with the ground. So for v final, it will have two components, x and y. So we have v y final, and this will be vx because velocity in the x direction won't change. And here we'll have vx and vy initial. So we want to find theta, or the smallest possible value of theta. So using this diagram, we have that tangent theta equals vy final over vx. So in this diagram, if we call this angle alpha, then we know that vx equals v cosine alpha. And so basically when we want to find the smallest angle, we only want to use what the problem gives us and any other constants like gravity. So we're putting everything in terms of v and h. So that gives us vx, and vy final can be found using the kinematic vy final squared equals vy initial squared plus 2gh. We know that vy initial equals v sine alpha, so if we square this, that'll be vy initial squared plus 2gh. And if we square root this whole thing, then we get vy final. So right now we have that theta equals the inverse tangent of the square root of v squared sine squared alpha plus 2gh over v cosine alpha. Because inverse tangent, because theta equals inverse tangent of vy final over vx. So, the only problem with this is that alpha is not given in the problem, so we can't use it in an expression of theta. But if we think about like what alpha could be, we think about like how the what happens as alpha gets larger or smaller. So if alpha is 0, then the initial velocity will be horizontal. That's not horizontal, but it will have no initial velocity component in the y direction, which means that the velocity y final will be smaller. So as alpha decreases, the velocity in the y direction, the final velocity, also gets smaller. And we would want that because and of course vx doesn't change based on alpha. So we would want vy final to be smaller because if we think about an inverse tangent graph, kind of looks like that. So the smaller that vy final is, the smaller the value that is plugged into the inverse tangent function, And you can see like as you go along this way, because that's when Vy final gets smaller, we get closer to 0, which means that theta will be closer to 0, and that's what we want. So the smallest value that alpha could be would be 0. So alpha equals 0. And if we plug in 0 for alpha, then we get that theta equals the inverse tangent of square root 2 gh over v, which is the final answer.